Hello everyone, my name is Fernanda Nayeli and today I will be presenting my poster that name is Synthesis of Bismuth-free nanoparticles from bismuth citrate by microwave irradiation. This project will be present at the A10 Symposium of the 29th International Material Resource Congress. We're gonna start. In the abstract, I'll talk about a bismuth ferrite is a very promising material for applications like hydraulics, energy, memory device, photodegradation of pollution, and amongst others. Due to its chemical stability, lead-free composition, ferroelectric, piezoelectric natural, and optical performance. The bismuth precursors generally used in the synthesis of bismuth ferrite are nitrate salts and chloride salt, which present the use a strong acid to dissolve the reaction and then used to basic granite to generate the favorable reaction environment. A bismuth citrate precursor saves steps in this methodology by elimination the use acid. In this project, was carried out the synthesis of bismuth-free nanoparticles starting by bismuth citrate as bismuth precursor. Moreover, the synthesis was performed by microwave assist method. Microwave irradiation has been shown like a time-saving, grander and low-cost technology. The experimental results showed the absence of bismuth citrate using an eco-friendly conditional of synthesis and the degrades in particular signs when ammonia is used. This material could have a enhanced performance in energy and photocatalytic application. Now I explain the method that I use. All chemical drainage were analytic grade purified without any purification process. Microwave assist synthesis was employed to prepare the ferrite bismuth. Wi-Fi, we prepared a cool solution of iron nitrate and iron chloride, and two solutions of bismuth citrate, one in a aqueous ammonia and other in a hydroxy potassium hydroxide at 0.3 molar. Sequentially, 10 ml of iron solution went added drops by drops and 10 ml of bismuth citrate. In agitation for 0.5 hours in a ultrasonic band. The rad was carried off in a conventional microwave for 5 and 2 minutes and 10% of dominant power. Then, the resolute solutes was separated by rapid filtration. The salts were washed with distilled water, only a neutral pH in results. Finally, the SEMs were dried to 16 Celsius grade for 20 hours in a oven and were grouped for homogenization. Now I show you the result that I have. In a figure 1a, show the FTRR spectrum for chlorine and potassium hydroxyl experiment with a time variation of 50 and 30 minutes respectively. At first glance, we can observe the similarity of one spectrum to the other, only by variation or intensity of one signal. In both spectra, a wave is observed in the range of 3700 to 2800. Is attributed to this one, is a tribute to a strange vibration or hydroxyl group. This same group presents a second band to 1638, characteristic of a benzyl vibration of the hydroxyl. This and this. This presence of this band is due to the excess of water in the sample, which was not fully evaporated at the time of calcination of the same. We can also observe a signal for the citrate ions starting with the bonds found in the range of 2915 to 2815. This signal and this. These bands are characteristic of a strange vibration of the alkali group. On the other hand, the functional group carboxylates disolver the present two types of bands. The first signal present in the range of 1645 to 1319 are a signal to the vibration mode of a asymmetrical strength. These bands and this and this. Insert the bands in the range of 1353 to 1715 are corresponding to a vibration of a type symmetrical strength. In the figure 1b, shows the FTR spectrum corresponding to the chlorine and ammonia experiment, where the same band that we observed in the figure 1. However, a small signal is observed in the range of 3000 to 3014, overlap with the strength band of the group. The signal corresponding to the ammonia group strength band, which is present in a new reflection medium, is this one and this. Other results that I have is thus the figure 2a shows the X-ray pattern of ferrite powders corresponding to the chlorine and potassium hydroxide for different reaction times. The low intensity in the peaks indicate low crystallinity due to the reaction time and very small particles. These observed peaks are a signal to planes to plane 104, 110, 202, 024, 214, and 220. This plane is characteristic for the bismuth ferrite. The figure 2b corresponded to the experiment to chlorine and ammoniac experiment to 50 and 30 minutes correspondingly. It's observed there is a curve the affinity to the peaks as well as the intensity different at each other. The peaks corresponding to the impurity describes the different pair corresponding to the perovskite structure to ferrita increase. The result of the chlorine and ammonia or 30 minutes experiment is the most favorite since shows more definition peak compared with the other experiments. Its emblematic grace crystallization was article in a reaction medium. The presence on impurity with respect to the grades 25, 14A, 54, 59. This corresponding to a structure more like selenite, like with there is a peg to ounce assigned to the small part to purify to the ferrita, which with the increment in a reaction time relation disappear. For the end, in conclusion, the BFOS was successfully prepared by the process synthesis. Using a microwave-assist method, we know to need a hydrothermal equipment, and by using a citrate bismuth as a bismuth preserve. This is concordant with the diffraction observed that corresponding grades to the plants 104, 110, 210, and 024, respectively. However, using ammonia achieved better same crystallinity by incrementing the reaction time for 50 and 30 minutes, which is evidenced by more definition signal and less noisy in the diagrams. Well, for the last, this is my reference that I use for comparing the result that I have with the literature. And this is all. Thanks for your attention and have a good day.